Welcome to this Design Automation with iLogic webinar. My name is Clint Brown, and over the next 15 or so minutes, we're going to run you through everything you need to know about getting started with iLogic for Inventor. So we're going to cover quite a few different topics. We're going to start out by having a look at some of the code-free elements of iLogic, so things that you can use straight away without knowing any code at all. We're also going to look at creating our first rule, and we're going to look at some of the standard snippets that come with Inventor. And from there, we're going to have a look at some real-world examples, as well as a short overview of Configurator 360. So iLogic itself is rules-based design. The idea is that you don't need any specific programming expertise to get started. We can embed design intelligence directly into models. It's a really simple way to control complex design variants, and we can automate tedious design tasks. Okay. So iLogic itself actually started out as a third-party plugin for Inventor. It was developed by a company called Logimetrics from Canada, and Autodesk purchased them in December of 2008. And since the 2011 release of Inventor, it's been a standard part of Inventor and the product design manufacturing collections. At the time of the acquisition, Logimetrics had this little bit of blurb, and they said individual engineers and work groups will have the ability to more easily capture design intent directly into digital prototypes and to create digital prototypes through automation without requiring any programming. Okay, let's have a look at what we can do with iLogic straight out of the box. First off, we get multi-value parameters. You've probably seen these in Inventor, and this came directly from that acquisition. We can create user forms, we can place iLogic components, we can create internal and external rules, we can create event triggers as well. We're going to cover each of these in a little bit more detail as we get into the webinar. So to start off, our focus is going to be on new users, people that have no experience of iLogic. What can we do straight out of the box without any programming knowledge? Well, we've got three really useful things. The first off are multi-value parameters, so the ability to have multiple values for a specific parameter. The next one is the ability to create our own user interface forms, and the third one is to place iLogic components. So we're going to do a little deep dive on each one of these. So first off, we're going to start with multi-value parameters. Inside of Inventor, we can go to any parameter, change its value, and our model will update. Now, this is something we learn on our first day of Inventor training, and it's really standard design practice inside of Inventor. But we can right-click on a parameter and go Make Multi-Value Parameter, and by inserting multiple values at this stage, we can use these as standard sizes for this component. So here we've added a bunch of different parameters, different values for the parameter, and when we now select one of these values from our drop-down, you'll see that our model updates accordingly. So we've now built some design intelligence directly into our model without knowing too much about any code at all. We've just edited a parameter. Okay, so that's the first step of our design automation already done. What about user interface forms? Well, in Inventor, they're really easy to do. The first thing we need to do, though, is enable our iLogic environment, which we can do through the model browser or through our user interface. And once our browser's up, we'll see that we have a Forms tab, and clicking on that Forms tab, we can right-click and choose Add Form. This will bring up our Forms interface. You'll see on the left-hand side that all of our parameters that we've named are available. We can just drag these into our white area over there, and they're displayed on the form. You can see I've dragged in the splitter, and then additional parameters. And from here, I can even do things like fix a spelling mistake. So length was spelt incorrectly in the parameter, but now the display name will display correctly once we update this. I'll also add in a picture, which we can then drag to the top. You'll see on the right-hand side that we're getting a preview of what our form is going to look like. We can then give this image an actual image to display. And I can then go in and change the visual style of my form. I'll give this a dark style, and I'll say OK. So now if I click on my form, I can see what it looks like. We can also dock this inside of our browser. And you'll see that our form is called Form 1. So we're going to edit the name of the form. We're going to change it from Form 1 to, say, Box Size. Once we've done that, you'll now see Box Size displayed over there. And every time we click on it, we can now see our parameters. Our drop-down shows us all of our multi-value parameters. And this actually affects the size of this component straight away. So really nice, easy way to get started using multi-value parameters and a form. We can also change the way that the form behaves. So there's a predefined buttons area, and we're going to change this from not having any to having apply, close, and cancel. This means that we can make multiple changes to our model without it updating. So here we're going to change 4 or 5 different parameters. Here we're looking at that top flange size. We're going to change that to 25 millimeters. A little tab on the inside there. I'm going to change that from 20 millimeters to 50 millimeters. And now when I hit apply, it's going to apply all of these changes to our model. So you'll see our weld tab is bigger, our top flange is bigger, and our overall sizes have all increased as well. So in a very short period of time, we've created a user form and we've brought in parameters from our model. We've also used that multi-value parameter that we started with in the previous slide. All right, moving on a little bit. Place iLogic components. This is something that you've probably seen when you're creating assemblies. You've probably wondered what on earth it's all about. Well, it's actually a really useful way of creating new parameters. I apologize, of creating new parts that are variants from the original. So place iLogic components allows us to create an exact copy of another part. So let's have a look at it. If I go into a new assembly and I go place iLogic component, and I choose this component over here called part 4, it brings it in and it fires up this interface which shows me all of the parameters for that component. That's not the easiest way to work with this. So what we suggest is you go back into your part and you create a form for it, and then we edit the form, and there's a little show on place component area, and we set that to OK. Save this file. Now when we shoot back into an assembly and we place an iLogic component, instead of that parameters dialog, we're now shown our form. So I can now choose the size of the component I want from the form. And as soon as I've specified the sizes I'd like, once I place this in, that new size is put into my model. So I can then go in and I can repeat the process, place iLogic component, and this time we're going to put in a bigger version. So we've got sort of trays there that could act as lids, and now we'll go and specify the tub versions for the other side. And once we've specified our sizes, hit apply, and these come in. So to understand what we've just done, we've created exact copies of our original component, except that these are now individual. They're not linked to the original, and they have their own parameters set. You'll also see the part naming convention over there. Our original is called part 4. We've now created part 4-01 and part 4-02. So when you use the place iLogic components dialog, it uses that naming convention to add additional components. Okay, so let's look at creating a rule. To do this inside of our iLogic area, we want to click on our rules tab, right click on our part and go add rule. Always give your rule a name, and we're now able to see a little bit about our model. So all of our parameters are available, and we can start creating things like if statements. So I can say, well, if the length is greater than 750, then I'd like to put up a message box to say that the length can't exceed 750 millimeters. So here we're saying maximum length is 750 millimeters. And this could be for a specific manufacturing process, for instance. And then what I want to do is I actually just want to correct the length. So I'm going to say length is equal to 750, end if. Okay, so we save our rule. And now we're going to go and change the size of our box. So if we change the length from 500 to 800, we'll apply that. You see our error message comes up saying our maximum length is 750 millimeters. And as soon as we say OK, you'll see that our length is then corrected to 750 millimeters. We're now starting to build some design intelligence into our model. We're controlling how our model behaves. Okay, we can also go in and we can do things like look at the eye properties. So maybe I want my description to always be equal to length times width times height. So to do this, I'm just going to say that my eye properties value for description equals length times, then I'm going to find width, and then I'm going to add in times height. So you see I'm combining text fields with my parameters, and that iProperties description came directly from a snippet inside of my rule builder. So if I look at my project data there, you can see that my description is now 750 by 200 by 150. And if I clear that out and I put in test and I run my rule again, we're now expecting that to be overridden. So we go in, you can see that we're now at 750 by 250 by 150. So we can start controlling some of the information that's sent back to our model. I'm going to create a text parameter here called color, and we're going to make a multi-value parameter in this instance. So we're going to make a multi-value parameter, and I'm going to paste in a bunch of different colors. I'm going to set this to orange, and I'm going to say OK. Nothing happens, and that's fine because it's just a text parameter. But what we want to now do is we actually want to link the part color, which we're going to grab from our snippet over there. We're going to say that that part color is equal to our parameter, so user parameter. I'll click on user parameters, color, and I'm going to say save. And as soon as I do this, my model turns orange. So if I go back to my form and I edit it, I can now drag color onto the form. And I now have a drop down which I can control for the part color. So we can now choose any color from the list, and our part will update in accordance with our selection. So we're now we've made our first rule. We're now controlling the maximum size. We're understanding the color, and we're also controlling the iProperty for the description, which is pulling data from our parameters to give us the size. Okay, so here's an example of a part configurator. And similar to what we did before, if we specify a size, you'll see that our model here is updating based on those sizes. But if we were to specify something silly, so let's say we say 1500, we get told that our minimum value is 2000 and our model is corrected to 2000 to update and give us the size that we want. But Inventor and iLogic is not just about part configurators. It's also about time-saving utilities. There's lots of things that we can do with iLogic that allow us to be more productive. So a thing to think about is that iLogic doesn't change the way Inventor works. It just changes the way that you work Inventor. So here's some examples. The first one is the ability to check and report on a component. So if I run this rule, what it's doing is it's going away in the background and it's checking all of my models, all of my components for any parts that are called, that have a property, a material property, I should say, of generic or default. And it's giving me a little report. So that little report's coming back and it's telling me that my designer, in this instance, John Johnson and Peter Peterson, have specified components with a material of generic, and it's given me a little report that I can check on. So as a design manager, you can go back and talk to those users about fixing those problems. What about deleting and grounding all joints? So there's two use cases for this. One is you might open up a step file or a third-party CAD file, and it comes in with no mates or constraints. This will allow you to just ground everything in one go. But you might also have large assemblies that are running slightly slowly. You can go in and delete all of the constraints and all of the joints in one go. And this will actually improve the speed of your model when you open it up, because Inventor has to calculate all of those mates and constraints every time you open a model. And if you've got a bunch of components that are actually fixed in place, they don't really need constraints. You could actually set up the constraints initially so you get everything into the right place, and then you could delete and ground all of those constraints. So it looks something like this. If I have a look at my model, there you can see I've got a bunch of mates and constraints, and if I run my rule, it comes and asks me, am I sure? I'll say yes. It tells me a total of 3 constraints and 2 joints have been deleted. And as I do that, all of my parts are being grounded, and you can see that my parts are grounded over there. All right. What about automatically creating drawings? So there's several ways to do this. And in the example you're about to see, I did the simplest version of this, which was just to go and create a drawing and then to replace the model. So the link down the bottom left-hand corner there will take you to this. And all you really need to do is set up a drawing for your assembly files and a drawing for your part files. And the rule will do the rest for you. So this is what it looks like. If we right click on a part and go create drawing, it'll go and lay out those drawing views for me. We can then choose a scale and we can save our drawing. If we then try to create a drawing again, it'll actually say, well, there's a drawing that already exists. Do I want to open it? Here's an assembly example. So again, we can then scale that away and we can then save our drawing. And if we try and create a drawing of it again, it tells us it exists and it just opens up the drawing. It's a really simple way of generating drawings automatically. All right, what about automating DXF flat patterns? So you might create bunches of sheet metal components, and maybe every time you save that file, you'd like it to just spit out a DXF to a given location. Well, this is pretty simple. We can run a rule over here, and all it does is it exports out a flat DXF, which we can then open up inside of AutoCAD. So really simple. From our model, it creates the flat pattern and spits out a DXF. And again, code is available down the bottom over there. Another time-saving utility is the ability to automate drawing notes. So in the past, I've worked in different businesses where we've had notes that were in different languages or notes that we just used over and over again. And this utility uses a text file. So we place a text file in a specific location, and we can then just select the text file and place those notes on a drawing in a given area. You'll see that I have a rule over here. And when I run the rule, it goes and grabs these notes for me. But if we have a look at them, I have a notes.txt file, and these are my notes that are just in a text file, and save that. And when I run this rule, it puts them onto the drawing. So the iLogic code itself is available, and that iLogic code has the ability for you to change the location of the note as well. So those are just 5 time-saving utility examples, which I wanted to show you just to get you thinking about how you use Inventor. You know, it's not all about part configurators, which are great, and we need to build more of them, but you can also start speeding up some of your workflows by using these time-saving utilities. All right, so let's have an example of a product configurator. Here we have a little cat ladder. When I click on a form, you'll see that I can change the height of this. And if I go and specify a height of 500, I get a dialog come up and say the minimum design height is 800 and my model is corrected. And again, if I go and choose a normal size, you'll see that the rules are creating the cage for me and building my model quite nicely. But if I go and specify 6,000, I get told that the maximum design height is 5,000 and my model is updated. Okay, so we could then specify something bespoke, so in this instance 4,255 millimeters, and we can then go and have a look at the tabs. So there's 2 ways of mounting one of these ladders. You can just about make out the 2 tabs at the back there, and these can either be top mounted or side mounted. So if I change that to a side mount, from a top mount to a side mount, you see that our tab moves. And if I change it back to a top mount, we get a new tab over there. These are basically just specifying whether this is mounted to a wall or mounted to a roof. Once we've specified our model and we're happy, we can click on Create Drawing, and our drawing pops up. Now inside of our drawing, you'll notice that our dimensions need a bit of tidying up. So they're not quite in the center. We can click Center Dimension, and that'll move our dimensions to the middle. And we can then click on PDF, which will generate a PDF for us. So we'll do that, and we then have a PDF of that drawing. So for someone that designed these cat ladders every single day, they now have, you know, a couple of minutes to generate a really quick set of drawings and 3D models of their design. But we can put this into Configurator 360. So Configurator 360 is an Autodesk hosted cloud service for product configuration. And companies use Configurator 360 to create product configuration web applications for use by customers or clients. The idea is that any Inventor model with some iLogic running in the background can be uploaded to the service. The thing to note though is that this is a separate subscription to your Inventor or product design and manufacturing collection. It's not included in the collection and is an additional service that you will need to pay for. But let's have a look at what it looks like. So from our catalog, we can fire up our ladder, and you'll see that our form looks very much like what we saw before. And we can go and generate a model. So here we're going to go and create something that's 4,225. We're going to choose our mounting, which is currently set to side mount. We can change that to top mount. And once we're happy that we've got our design more or less where we'd like it to be, we have a few additional options. So from here, we can go and choose our exports. So you'll see that we can export to DWG, but we also have the ability to grab step files, SAT files, an AutoCAD drawing, images, or a 3D DWF. But here's our 2D PDF, and you'll see that it looks exactly like the one we had in Inventor. And that's because Inventor is being used in the cloud to generate this. We can also go and request a quotation. So here we can fill in our details. We can also ask to please send me a quote for 6 of these. We hit submit, and our model is now, or our request is now sent off. You'll see that in the request, we can see everything that the request has asked for, which is great. We can then view the RFQ details, and this will actually take us back to the web. Obviously, this is what the administrator would see, so they can see all of those details. The administrator is also able to go and download the actual model, clicking on that link there, or they can go back to the product configuration page. Okay, so what is our call to action? If any of this is of interest to you, speak to your account manager. We can help you out with iLogic training, or if you've got a particular project in mind where you need to automate the design of a specific component, have a chat to your account manager and they'll be able to arrange some consultancy for you. So thanks very much for your time, and we hope that you enjoyed this webinar.